Hi guys, okay, so now we're going to be teaching you how an AC generator works. So the first thing that you have to know is how Faraday's law works. Hear it?
Yes.
Okay, do you know about Faraday's law?
What law?
Faraday's law. It's the law that states that a change in magnetic flux will generate a current in the wire.
What does that actually mean? I mean, like,
Okay, hold your hand like this.
okay.
So then what Faraday's law said is that if I pour a
Dude!
It's okay, it's okay. If I pour a changing magnetic current through a wire, the amount of current that generates in the wire there will be current in the wire.
Okay.
And that depends on the change in magnetic current. So if let's say I pour a lot of water, then there will be more current. And if I pour less water, there will be less current.
That's a really good explanation, Tim.
Yeah. And one of the few ways that we can change how much current is generated is by increasing the size of the coil.
So that means if it's this small, yeah, that really makes sense, because if you were to make my hand this small, then only so much water can go through. I mean, not over my hands, but in the hole.
Now make your hands bigger.
Yeah.
With two hands.
Oh, yeah.
Then there can be even more current. Okay,
Yeah, I think you finished all my water, so God damn it.
Okay, so thanks, Kirit.
No
Okay.
problem.
Okay, let's
Thanks,
go.
Mar.
Okay, so now that was the first part of an AC generator. Now the second part is just as important. John! John! Now, do you know what LENZ'S law is?
That Form 5 physics thing.
Okay, so I'm gonna tell you more. Okay, because you don't know anything, John.
Alright.
Okay, so
Enlighten me.
what LENZ'S law is that it states that a change in current will be caused by the direction that a current flows due to a change in magnetic flux. It says that the current will go in a certain direction to go against the change in magnetic flux with its own magnetic field. So you see, let's say the current is going upwards, right? So what happens is that the direction that the current moves will go against the change. So like, let's say it's increasing upwards. So what happens is that current will go this way, because your right hand grip rule that we learned from Mr. Tan says that the magnetic field will go this way, right? So if it's increasing this way, it will go this way. So it will go around here and go down, because it's increasing, it's reducing the change. Now this is because of conservation of energy, which states that the amount of energy present will always stay the same. But you see, if it went the other way, then it will just push it out of control. And the system would not be possible. So that's what happens. Yeah, pick it up, John. Okay, thanks, John. Okay, so if we combine both things that we learned today, Faraday's law and LENZ'S law, what we get is this generator, AC generator, which is able to generate alternating current that changes direction every time after each round. So, if we analyze this graph, we can tell that to determine which way the current will go, we can use our right hand rule, okay? Because it's the right hand of God, and G in God is for generator. So what we have is the force, which is the direction of which the coil is turning. This is the magnetic field, and this is for electrical current. So come, Tisha, let's come, and we can talk about the graphs. Okay guys, so now we're gonna talk about the graphs related to our AC generator. So come look. So we have two different graphs. Okay? One graph is magnetic flux over time, and our other graph is EMF, our voltage, as it changes with time. Okay? So then for our first graph, if we start in this position, then magnetic flux will be zero, because there is nearly no magnetic field passing through. Okay? However, when at this position, EMF will be high, since at this position it will be cutting a lot of the field lines, which leads to changing magnetic flux, so which is why it will be high. And then as the coil turns into this position, which is a lot of the area is exposed to the magnetic field, then induced EMF will be zero, because there is no change in EMF, it's constant. And then if we continue this graph, as the coil turns more and more, we get a sine graph. where each point is related to each other. Okay? So we get two sine graphs. Like that and like that. So then, now you see guys, if we use our AC generator, power an AC motor, the turning effect that is generated by the AC motor will create its own induced EMF. Because a turning force in a magnetic field will cause a change in magnetic current, and this will change the magnetic current. So come see. Okay. So see, this is the graph of the induced EMF from the generator to the motor, right? But you see, if we have the induced EMF created by the motor itself, what we get is here. We will have all the same unique points, but it will just be smaller and it will be opposite. So what we get is this. So what happens to this is that the actual EMF that is received by the motor will be a lot more weaker due to this back EMF, which is a pain in the ass for engineers. Yeah. Okay guys, so now that we got the graphs covered, so let's move on to equations involved in our AC generator. Okay, hi guys.
Hi!
So do you guys know what the equations involved in an AC generator?
I'll look it up.
Yeah. So see, the AC generator, it requires two equations which are very simple and very straightforward. So yeah. See, this is one of them. Thanks, Kirit.
No problem.
So this is magnetic flux. This is the symbol for magnetic flux, which I'm not sure what it means, but it looks very cool. And this B here represents magnetic field. And the A is for the area of which is exposed to the magnetic field. So through this we can calculate the total magnetic flux that passes through a given area. Okay?
Hey, I got another one too.
Huh? Oh, okay, good, John.
Yes.
Okay, so this is the voltage that is generated from a change in magnetic flux. This represents the change in magnetic flux because of the triangle, and this represents the time taken for that change to occur. And this N here represents the number of turns of coil that are present in the equation, and the negative isn't really important, but it just exists there to show which direction the current will travel in order to neutralize the changing magnetic flux. So yeah, that's it. Okay guys, so that's all you have to know for the AC generator. So then thank you to all my teammates, Kirit, John, and everyone else. Yeah, and then if you have any other questions, you can ask now. Thank you.